All right, so there's another one of those. If you see it in this form, you've only got one substitution you need to worry about. So if it's dy dx equals f of, and you can see the pattern there, then you have the direct u substitution. So let's have at it. Dy dx equals parentheses negative 2x plus y quantity squared minus 7. So according to the pattern, my u is going to be negative 2x plus y. And let's see, so it's probably easiest to do this in terms of x. So let's do dy dx, which would be negative 2 plus dy dx. And then if I rewrite that in terms of dy dx, so dy dx then would be du dx plus 2. Okay, so let's go back up to our original equation. So our original equation was dy dx equals negative 2x plus y squared minus 7. And swap out dy dx for du dx. Plus 2 equals u squared minus 7. All right, so that's going to give me du dx equals u squared minus 9. Okay. So at this point, I'm going to pause and go, whichever methods looks pretty easy to use, and separable equations looks pretty nice. So that would be 1 over u squared minus 9 du equals dx. All right, and now we get to run into one of my favorite skills from pre-cal, partial fraction decomposition. So I want to separate out, okay, so let's look at the denominator. U squared minus 9 is 1, we can factor as u minus 3u plus 3, of course du, and then dx is pretty straightforward there. Okay, so we want to hang out with this 1 over u minus 3u plus 3. So there should be a way, I'm going to rewrite this here just a second. Should be a way to separate this into two different fractions with some constant up top. So there should be some way that I could separate those two. And that's where that process of partial fraction decomposition comes out. So on the right side, if I was going to, sorry, I got button click happy there. If I was going to solve for a and b, try to make them be common denominators, right? So u minus 3, u plus 3, that would be a times u plus 3 plus b times u minus 3, and that would equal the original fraction. Okay, so up top, and I'm just going to focus on just the numerators for right now because I've got two fractions with equivalent denominators. So that says a times u plus 3a plus b times u minus 3b, right? So that all that has to be equivalent to 1. So what do I know? Well, I don't have any u expression on the left side, so that says the au plus the bu has to be equivalent to 0u, or more specifically, a plus b has to equal 0, so that means a is equal to negative b. Okay. The other side, the other 3a minus 3b, So that says 1 equals 3a minus 3b. And we can use the what we just found. So that's 3a minus 3 times, so b would be essentially negative a. So 1 equals, that's going to give me 6a. So a is 1 over 6, and b would be negative 1 over 6. All right, so let's jump back to our integral expression there. So now I've got 1/6 over u minus 3 plus negative 1/6 over u plus 3 du, and I have a dx on that side. And if I integrate, so let's integrate both sides there. So on the left side, I'm just going to have a bunch of ln's. So 1/6 ln of u minus 3 minus 1/6 ln of u plus 3. And on the other side, we'll just have our x plus a constant, and I'm just going to name that C1 for right now. And let's see, I can combine, let's see, I'm going to factor out the 1/6, and then I'm going to use my ln rules to simply get it down to a single expression. So that's going to give me u minus 3 over u plus 3 equals that x plus C1. Let's multiply everybody by 6. So ln u minus 3 u plus 3 is equal to 6x plus 6c1. And then I can raise those, do that log rule about e raised to that power. So e raised up there. So that's going to give me u minus 3 over u plus 3 equals e to the 6x plus 6c1. And let's see, what else? I can separate out the e. Oh, off my screen there. So e to the 6x times e to the 6 to the c1 power. And we've kind of seen this conversation before. That is a constant term, which I can just rewrite. So u minus 3 over u plus 3 equals some generic constant, e to the 6x. All right. Now what? Let's see if I can do something about isolating out u. It'd be nice if I had a nice single expression in terms of u. So let me get some more space here. So u minus 3 over u plus 3 equals c e to the 6x. And let's multiply by u plus 3. So u minus 3 equals u plus 3 c e to the 6x. I think we can do a little bit of distributing, I guess. So u c e to the 6x plus 3c e to the 6x. All right, and then let's bring the u to all the same side and move the 3 over. So that's going to be u minus u c e to the 6x equals 3 plus 3c e to the 6x. And I think we can factor a u out. So 1 minus c e to the 6x. We could, yeah, why not? Let's factor that 3 out. And then we can divide. So u equals 3 times 1 plus c e to the 6x over 1 minus c e to the 6x. Okay, now let's replace u with that expression we had. So u was negative 2x plus y. All that lovely stuff. And if I wanted to solve for y, that's just moving the 2x over. So 2x plus 3, 1 plus c e to the 6x over 1 minus c e to the 6x. And normally, the past couple examples, we just stop and say yay. But we have that initial condition from the start. So the initial condition was y of 0 equals 0. So if I put a 0 in there, so 0 equals 2 times 0 plus 3, 1 plus c times e to the 6 times 0 over 1 minus c e to the 6 times 0. All right, so c 6 times, so that's e to the 0 power. So both of these, that becomes 1, that becomes 1. So we're left with 0 equals 3, 1 plus c, and 1 minus c. Of course, the only way a fraction is ever going to equal 0 is if the numerator equals 0. So that says 0 equals 3, 1 plus c, and that then would mean c is equal to negative 1. So put that all together for our final pretty answer. So y equals 2x plus 3, 1 minus e to the 6x over 1 plus e to the 6x.